Okay, so we're picking up from where we left off last time. Let's actually go back and let's deal with this demo again. This was the crux of the new code. This code said, try to open a file that didn't exist, and it would catch one of the exceptions. Why is it important to have multiple catch blocks? That's why it would happen, but why would we catch things differently? At the end of the day, we can't open this file, right? There could be different problems. So depending on what kind of problem you face, there might be a way that you can recover from certain types of problems. So in the catch block, you would do that and then continue from there. Okay, so let's go back to Visual Studio, handling exceptions. So we actually did a few other things. We started off with some file. Okay, and some file, if we run this, gave us an error because some file doesn't exist. It's not up there. Oh. Where's the display? Can't capture the display. Can CFox it. Can see Visual Studio. All right, we're gonna run it like this today, and maybe, oh wait, can I go back to this now? Better. Okay, good. Okay, so it's gonna be a little bit different when we're looking back at this, but there's the result. It says cannot find some file.txt, specifically because it doesn't exist. That's due in large part to the fact that the catch block has a file not found exception. When you use these exceptions, and on Friday I think we're actually going to have a lecture, it's nothing but exceptions. You can actually take that as if it was an object, and you can print the whole exception, and it's going to look rather familiar. So there's the exception E, and it's a file not found exception. If I rerun this, oh, okay. So what do we see here? We see cannot find some file, and then a bunch of stuff. It actually goes on for some length, far beyond what you can see. But specifically, the first thing it prints is, hey, file not found exception. So E contains all of the information about that problem that just occurred. It's a file not found exception. It tells you what the file name that you were trying to find was. So in this case, it's users, username, documents, Dropbox, teaching, 264 demos, the name of the project, handling exceptions, /bin, /debug, /some file. This is important for you because in Visual Studio, where you put the file matters. Sometimes you need to put it with the CS file, sometimes you need to put it in the bin directory, sometimes you can put it in either, sometimes you put it in neither. But this at least tells you this is where it was looking for the file. So when you say some file, some file is defaulting to /bin/debug. So that's where you have to put it in order for it to be found. Or you have to use something like this, a bunch of dots to go up from that directory. So if you think about where bin is, and actually, yeah, it's still up. So if you go up one directory from debug, then another directory up from debug, then you're in handling exceptions. Handling exceptions is where the handling exception.cs file is. So when you actually function home laptop keyboard. So if instead string is a file that does exist, and we run that, close that down. This one successfully executes and starts printing out the lines in the file, because we gave it the exact path. I think here this is something that you might want to notice. I'm interchanging forward slashes and backslashes. C# in Windows will handle either. When we get to homeworks and labs involving files, which is still a few days away, you're going to be compiling and running the test on Linux. When you push and it goes to Travis, that's actually going to be compiling on Linux, and it does care. So when we'll talk a little bit more about how you can deal with the slashes in a bit, maybe Friday. All right. So be aware that if it runs and you run the tests on your machine and they all pass, but then you push them to Travis and they fail, first thing to look at is the direction of your slashes. Okay. So the last piece of this demo is if we use a directory that doesn't exist. So sumdir definitely does not exist. We get a different handle. So what if we were trying to write to a file? If we were trying to write to a file and we got a directory doesn't exist path or exception, what could we do? You could make a directory and then try to open the file. Yes. Now maybe you can't make the directory because you don't have permissions in that path, and that's different things. Okay, but so the point of this demo was multiple catch blocks can cause things to happen. So if I were to somehow delete the file in the middle of this read to end, I'd probably get some kind of an IO exception, generic IO exception. Everything actually is a type of just something called an exception. But IO exception is a type of exception. Okay, back to OBS. Clocks and slides. So here we are back in our slides. So moving on from here, other things we can do with files. More examples. So here's a little snippet of code, opens up a file as a stream reader, reads the whole thing into a string, and then it uses a method of the string class, index of. This is very much like string in C. It tries to find the index where some text occurs. It does it using a linear search. Starting at index 0, it says, does index 0 equal an F? If it does, it tries to see if index 1 is an O, and then 2 is a U, so on and so forth. If it finds all of the letters in found me, it returns index 0, because that's where it started. If at any point it fails in finding any of those letters, it moves on to the next index. So it starts searching at index 1 for found me, and then index 2 for found me until it finds it. So while index does not equal -1, that would be the error value, the return value if you cannot find it. Say count ++, and then find the new index, starting at the current place you found afterwards. What is missing in this code, and what is that? Oh, that's the answer. You don't see it. Go away. Go hide. You can't see it because it's behind my head. It's almost like I might have done this before and just forgot that I did it. So what's the problem with this program? This is actually a file problem. It's not an algorithmic problem. The file is never closed. And that's a problem because that means no one else can use the file. So with a bit of movie magic, the using statement. If you encase this in a using statement, you're going to be better off. So where would you put this using statement? Does this work now? No, it still doesn't work. I don't know what I've done to break this. The using statement would go around any file I/O operations. So where is the first file I/O operation?
Stream reader?
Well, it's mentioned several times. Be a little more specific.
The one at the time.
No. All right, so that actually creates an instance of the stream reader object. Question? It would be the .read to end. That's the first time we actually access the file. So before that event, we should start our using block. Now, where is the last stream reader operation? Nope. That's the correct answer. That's the only stream reader operation. So that's both the beginning and the end of it. So as soon as you create the stream reader object, called stream reader in this case, you can say using and say string text equals stream reader read to end. Close the using, because that's when we're done. We no longer need the file open after that point. We have allocated an entire string to the entire file. This is a terrible way to find things in a file. It's absolutely awful, because you have to allocate all of the memory for a file. How big are files these days? Megabytes, gigabytes. You don't know. You don't know. Is there air out there? It's Galaxy Quest. Best Star Trek movie that isn't a Star Trek movie. Tim Allen. Sigourney Weaver. Tony Shalhoub. Sam Rockwell.
What was it?
Galaxy Quest. All right, frowny face. Get out of here with that midsummer shenanigans. Next slide. Counting word occurrences. I'm not going to demo that. And actually, we don't need to deal with the subtitles because that just tends to confuse people. Okay, so this is sort of where we stopped last time. And I just want to have one more demo, take a little bit of time, and really show you what's going on. So the stream reader class has read line just like the console does. Stream writer has write line just like the console does. Using try, catch, and finally is another way of dealing with exceptions. So by now, many of you have been dealing with the lab. You had it on Monday and Wednesday. Still, about a third of you need to go on Friday to do with the lab. I'm going to encourage you to use try parse in the lab. We've talked about try parse, getting numbers. With a try parse, you do not get an exception. You get a return value of true or false. If you wanted to use int.parse, you could use that inside of a try block, catch the exception, and we saw that there are two exceptions that can be generated by a parse, right? What's one kind of exception? Or what's a value you could enter to give an exception in parse? Bob, what's the other thing you could do for int.parse that would cause an exception? 6 billion. Anything over a 32-bit integer size, right? So you'd actually get two exceptions, and you could handle them differently. You could yell at the user in two unique ways. Bob is not a number, or, hey, that number's way too big. Dial it back about 30%. Actually, you could. If I had you, you could enter a number. It could parse it as a larger number, like a double or a float or something, and then it could figure out how far back you needed to dial it back. Wouldn't that be fun? Homework. Oh, this is going to be a great homework. I'll have to make a thing. Make it into a homework. But automated tests. Automated tests. Just run the tests, move on with your life. Sure. There's one go-to fact about users. That they are the dumbest people on the planet. If they can break it, they will. They'll find a way. There's no such thing as a user-proof program. You think Bob is the worst they can do? What if they start typing in Unicode characters? They copy and paste things off of the Chinese internet right into your internet? Those characters aren't ASCII renderable. What is going to happen? I don't know. Well, I don't know. I mean, we could try, we could find out. What if you paste the eggplant emoji into your program? What happens then? All right. So before we move on to a new topic, any question on text files? How do you open them?
Open it with green.
I think we're going to institute a hand-raising rule.
Oh,
And then you will wait to be recognized. Yes. A stream reader class. That only answers the question if I was asking about reading from a file. What about writing for a file? Writing to a file. What was the rule we just instituted? Raise your hand. Stream writer. Yes. Okay. So we got stream reader and stream writer, reader and writer. Two different classes depending on what kind of operation you're going to do. Question.
Yeah. So we've always talked about TXT files. But can we do TXT files or something?
CSV files are just text files. TXT is an extension. We have not talked about binary files that have binary data. This is printable characters that we're dealing with. Whether or not they're in Cyrillic or Chinese simplified or plain old ASCII, this will work. You just have to open it with an encoding. So we talked about how to open with Cyrillic encoding, Windows 1251 kind of thing. We will not deal with that. I will give that to you at a later time. Okay. So now we need to get into some more interesting stuff. And to be on topic, we're going to go right into exception handling today, I think. So let's just keep on keeping on with the exceptions. We've done try parse. We've done try catch finally. Let's talk about other bad things that can happen while you're running. Because what's Murphy's Law? You're learning. Anybody else? Anything that can happen or go wrong will happen or go wrong. So, what are exceptions? We kind of already know. Can somebody just guess what is an exception? What's like a good second row? Something that breaks the normal flow of execution. Okay, let's get right into it. What are exceptions? They are the paradigm of exceptions in OOP, capital O, capital P, object-oriented programming. And that's the last time I'll ever get that excited about that. All right, exceptions are an implementation of the exception model. So there's like history that we're not going to go into about why exceptions are a thing, but they're a pretty powerful mechanism. That's not marketing, that's a real thing. They handle errors and unusual events. For common errors, you should still test for them, if bad thing, okay? But for unusual things, they do make your code look a lot nicer. They make it a lot cleaner. One of the things we haven't covered is that they're central. If you have a function, just a plain old function, that throws an exception, the first thing C# is going to do is it's going to look inside that function to see if there are any try-catch blocks. If it doesn't find in that function, it's going to kick it up to the function that called it. So if you have getNumber, which many of you have in your lab, you could write it with int.parse, and it would throw an exception when I typed in Bob. Right? Int.parse throws an exception for strings. You don't have to handle it in that getNumber function. You could handle it in the thing that called getNumber. Something you could do. So it's pretty powerful in terms of nested levels. Okay. It does simplify the construction of your code because it's not going to be littered with a bunch of tests. If, the file exists, and if the directory exists, and if the something else is true, and if the network share is mapped, and if you're connected to the internet, then try to open this file and send it to the internet. Assume that the file exists, and if it doesn't, complain. Yeah, that last thing, processed at multiple levels. Maybe at the lowest level of your function, you cause an exception, and maybe you can partially handle it, but not enough to like continue on. So you say, you throw a different exception. All right, I kind of tried to handle this, but it didn't quite work. Can somebody who called me handle this a little bit more gracefully? Okay, so we've seen the try and the catch block and the finally block, and you can have multiple catch blocks. So this is review. Who was holding the bomb last lecture? Which Batman? Adam West Batman, that's right. So here you've got a different kind of thing. We're going to try to do an int32 parse. Int32, by the way, is the same as int. Int32, though, is the .NET framework name. So if you go to Visual Basic or F# or any other .NET language, int32 translates across. Int is sort of special to C#. Okay, so by its very nature, we try to parse it, and we've got our two exceptions. Format exception says Bob, or is for Bob. Overflow exception is for a number too big. In fact, I think I wrote this exact code like weeks ago. The main thing we want to accomplish is we want to parse an integer. That's all we want to do. We just want to get a number. But bad things can happen. You can accidentally finger hoof and press a letter instead of a number. We can put in a number that's way too big. And this is sort of protecting you from bad things happening. Now, in the normal flow of execution, you wouldn't expect somebody to type in a number like 18 quintillion. It's just not something that comes up very often. But if somebody accidentally leans on their laptop or their cat decides to walk across the keyboard at an inopportune moment, bad things are going to happen, and you don't want to just like dump the user out of whatever they're doing. What if they've been working on something for like 2 hours and haven't saved? Wouldn't it be better to just like recover from that? So you could test and you could say, all right, if the length of the string is greater than 7, probably it's bigger than I think. You could look for the index of any alphanumeric character. You go through to a linear search if it's not a number. Or you can just sort of assume that it's a number, and if something bad happens, handle it. Okay. Now that could just be as simple as setting a flag, going back up to the top, and trying again. That's allowed. I don't think we need to do this for a demo. We did this last time. I think we're okay. It's going to, depending on what you type in, it's either going to give you a format exception or an overflow exception. Okay. So exceptions are objects. Okay, there are lots of classes of exceptions. Format exception, overflow exception, IO exception. We've seen like 5 or 6 now. They are all objects. Different classes define different things, but they're all objects. And the system.exception class, it's actually a base. Everything is related to this exception class. And it contains a lot of useful information that all other exceptions also have. They have a message, big, too big. They have a stack trace, which is usually what you see, like this line called this line called this line, which broke everything. And then they can have something called an inner exception. So an inner exception is what happens when something tries to handle an exception and fails and throws their own exception. What they'll do is they'll nest their exception that called them. So in the case of this, if you had a format exception and you wanted to create some your own exception, you could throw your own exception and you would nest in that format exception into your exception. So you could actually trace it back all the way. It's not for users, it's for coders, okay? And it's a way of figuring out what caused the exception that eventually got to you. You don't have to use one of those. It can be anything. It can be null. So here we've got a program that causes an exception. It's hard-coded in there. An invalid number will never parse. That's the name of the string, invalid number. That's never going to work. So when you call it, it's going to trigger the catch block, a format exception. And in this case, we are actually using that exception in our catch block. So FE is going to be the name of our exception. Catch, format exception FE says we're going to actually use this format exception as the variable FE. So when I use FE, it's an object. I can access the members of the exception class. In this case, it's the format exception class. But since all exceptions derive from exception, they all have messages and stack traces. So it's going to print the message and the stack trace and say that it's caught. Now, okay. This is the expected output. It's going to say exception caught because that's what we told it to print, exception caught. And then it's going to print out in the first position the message, on the next line the stack trace. The message, input string was not in correct format, that's user readable. Now, unless you have access to the source code, the stack trace is not particularly helpful. It says parse int32 string number styles number format info. That is the thing that actually broke. That's what caused the exception. That was called by int32.parse, which was called by exception test.cs line 8, which was called by the main function at line 15. So you go back, the main function called int32.parse, main function called cause format exception called int32.parse, int32.parse called system.number.parse int32. Does everybody follow what happened? At least until the point the exception happened. Main was running. Main called a function. That function called int32.parse. Int32.parse called another function, and that's when the exception occurred. It will give you a lot more information, like what the line numbers are, but you have to be in debug mode. Most of you will never leave debug mode because these are just student projects. But you can change it by changing the bug dropdown to release. Okay, so let's go in and we'll do this demo. Open project. Exception handling. And then I think I can go over here, go to Visual Studio. This is actually better in a lot of ways. Exception properties. Okay. So you can see that it causes the exception. I'm going to stop it after the exception occurs, but before we do anything. So this is guaranteed to cause an exception. It's just a trivial example that creates a format exception. So when it finally decides to run, it's going to break, and we'll be able to look at FE as a variable. So FE is here, and it is a system.format exception, but there's a lot more interesting stuff here. You can't see that because the thing is open. So can I do this and then hide that? Better, yes. Okay, so it says things like the message input string was not in the correct format. I know you can't read it. I don't think there's any way for me to increase the font size on this. The stack trace is just a string. That string is the whole path. Then there are other things like the inner exception, which is null. There's an H result, which is currently negative 2.146 billion. If I change that to a hexadecimal display, it's an 80131537. So what does that mean? Read the documentation. That's all I can say about that. And then there's data, like what data is associated with this. So there's a lot of information. You can really drill down into this, what the results were, empty, no enumeration, values, not a whole lot in there. We can add things as data that's part of the exception. But for the main purposes today, source, message, stack trace, and inner exception, which is null. So fe.message by itself doesn't do anything. It's just the English or human readable name for the exception. And that's it. The program ends because that's all there is to this example. I want to go now to here, here, go back to the slides, go back to the slides here. Okay. We're slowly starting to pick up some object-oriented topics, though. Everything is an exception. If you just did a catch for exception, it would actually catch all of the exceptions, regardless. As you go down this hierarchy of exceptions, you'll catch less and less stuff and be more and more explicit. So there's usually two sides to the exception framework. There's the application exceptions and the system exceptions. System exceptions are written into the .NET Core. Application exceptions are usually where you'll put your own exceptions, because eventually you're going to create your own exception classes that will be a little bit more specific. So something like an invalid student, you can make that as a class, and you'll be able to use that exception. So you'll be able to say new invalid student. That's a little bit more user-friendly than arithmetic exception. Now, arithmetic exception, for example, has lots of different subtypes. Anything that's an arithmetic exception will be caught by this type. But you could also specify, I only want to catch divide by zero exceptions or overflow exceptions. Okay? So those are things. Now, format exception is one that int.parse will throw. Overflow exception is something int.parse will throw. And you catch those specific ones. If I instead said system exception, I'd be able to catch both with one catch block. Does that make sense? So the higher up on the hierarchy I go, the wider a net I'm casting on finding bad things. Okay, the lower I go, the fewer things will actually go into that catch block. Okay. So everything inherits from exception. So if you want to catch something, but you don't know what it is, you can catch an exception. And user-defined things would go under application exception. So, yes, this is what I just said. Arithmetic exception, if you go back and look at it, it will catch both divide by zero exceptions and overflow exceptions. So if you're trying to catch a lot of things that all stem from the same problem, you can do that. You can climb the hierarchy. As well as things that are just arithmetic exceptions, because you can throw that kind of that exception. So this actually catches at least three types: divide by zero, overflows, and generic arithmetic exceptions. Here's a problem, though, with catch blocks, and it's something beginners will often struggle with. Catch blocks are like if-else blocks. They are evaluated in the order that they are presented. So, in this version of the code, you will never see invalid integer number or this number is too big to fit in int32. It will never get triggered because it looks at the width of the net for the exception in order. So if you catch exception, format exception and overflow exception are subtypes. As a result, they'll get caught by that first catch block. Does that make sense? Okay. So your catch blocks should go in order of most specific to most generic. Exception, being the most generic, will always be the last thing in your catch blocks, unless you're doing something really weird, but I can't think of any reason not to have exception as the last. You don't have to use exception if you don't want to. You can use just format and overflow, but if you are going to use the most generic type, it should be last. Okay. If you put nothing in there, if you just say catch, we will catch any kind of exception. It will catch the root exception, system.exception. So if you don't know what you're doing in terms of what error is going to pop up, you can just say try catch. It'll catch everything. Even unmanaged code, which is not something we are going to get into, unmanaged code is unsafe. In C, you could allocate memory and never free it. You can have memory leaks. Let's see, who are my freshmen? What year were you born? You were born in 2000. So in Windows 95, never thought this would be a thing. 5 years before you were born, the operating system that ran on all computers except for Macs, and even then in 95, Macs weren't a big thing, ish. I'm going to get like Mac people on the YouTube video. Mac was doing this and it had a mouse before Windows could even think of a disk operating system. What's wrong with A lot of memory leaks in Windows 95. It wasn't a perfect product, okay? Mistakes were made. But the start bar was pretty cool. Apple OS 2 had a start menu. What was I saying? Oh, unmanaged code. Unmanaged code is code that could just do whatever it wanted. C# and the .NET framework introduced the idea of managed code. You can't create objects that can just disappear off onto the heap and live forever. There is a scope of life for those variables, and they will die eventually. When they go out of scope, they will be destroyed. The memory will be freed and returned to the OS to use. It's managed. But you can still call unmanaged code, because lots of things are unmanaged, like serial ports. You can make a managed serial port class, but sometimes it's easier to just go into the raw DLL and extract that out and just call it. But unmanaged code can also throw exceptions. Okay, C++ can have unmanaged bits in it, and you can have exceptions thrown there. Catch will handle those as well. Okay. What the? Oh, it's a hammer throw. Frankly, all I saw was the kill. Okay. So far, we've only been catching them. We can create our own exceptions, which we say we raise the exception or throw the exception. In Python, you say raise. In C# you say throw. They both mean the same thing. Cause an exception to occur. In this case, it's the throw keyword. And you have to throw an object. You don't throw a class. You throw an object. What's the only way to create an object? What keyword will create an object? One keyword that we always use when creating an object. New. Yes, new. You were going to say new? I believe you. I recognized him first. Yeah, it's new. So you're going to create a new exception and throw that new exception. You can do it all in one line. Used to notify the calling code in case of error or unusual situation. When an exception is thrown, the program execution stops unless there's a catch block somewhere. The catch block doesn't have to be in the function. It can be in a calling function all the way up to main. Okay? So it will travel up the stack until it finds a catch block that it will recognize. If it gets all the way up to main and still cannot be caught, that's when you see the crash. That's when you see the error message and the whole program goes, nah. Okay, this is a little bit complicated to follow. So, do this. See my cursor? Okay, so here's main. Main calls method 1. Method 1 calls method 2. Method 2 and so on and so forth until it calls method n. Now, so we're deep in this call stack. We've called functions that have called functions that have called other functions. And in that bottom function, an exception is thrown. It will first look inside of that bottom function, see if there's any catch block that applies. And if it doesn't find one, it will go up to the function above that, n-1. Or yes, yeah, n-1. And it'll look in that function. And if it doesn't find it in that function, it'll go up again. And so eventually it gets up to method 2. No, nothing there. Goes up to method 1, and that's still no catch block. Goes to main, still no catch block. Main then comes back up to the Common Language Runtime, CLR, the .NET Core, and that displays the error message. You get a big error. So depending on if you're doing Windows programming or console programming, in console it'll display in the console. If you're writing Windows program or Windows-based program, it will actually put up its own little dialog box, but the program is dead. You're toast. So here is an example of throwing an exception. You get to provide the message, though. So you can choose the type of the exception and the message that will be thrown along with it. Remember, message is a member of exceptions. So in this case, you can provide throw an argument exception, invalid amount. So here we've got something we shall be familiar with, int parse, a format exception. What kind of input will cause a format exception? There are rules. He had his hand up, he was ready. He hasn't volunteered anything all class. What do you want to say? A string. Oh, he even gave a more generic and valid answer than you did. Well, actually, that's not true, because a string could just be numbers, right? It could be a string, 1, 2, 3. That's technically valid. So Bob, I guess, is a little more correct than a string. But an alpha string instead of alphanumeric. So a character string. So it's going to throw a format exception. But with a catch block, we can interrupt this flow. So instead of going all the way back up to main and crashing, we can find that, and we can actually throw our own exception. So that's an invalid number. And we throw a different type of exception. We throw an argument exception. So this is sort of, you can think of this as a man-in-the-middle attack. Our code that we called, int32, it threw a format exception. We caught that. We said, nah, it's not really the right name for this. We want to pass something a little bit more instructive up to our user. It's an argument exception, because you provided this. Format exception can happen for anything that's formatted improperly. But an argument, you provided this as an argument to the program, like get number. So then you throw an invalid number argument exception. Invalid number is the message. Argument exception is the type of exception. And furthermore, you nest the original error. FE is the format exception object. It's the object that was created when parse blew a gasket. So you put that in as the inner exception. This is standard practice. If you're going to throw something from a catch block, nest the inner exception. If the original exception is not passed, the initial cause of the exception is lost. And that's exactly why you do it. The stack trace for FE is going to actually lead you back to that parse command. If you don't, it's only going to go back to the function itself. You won't know where in that function it actually occurred. Okay? Sometimes you just want to do a little bit of extra and then pass the buck. So in this case, we're still catching that format exception. We're printing, hey, parse failed, and then we're throwing that same exception. Remember, you have to throw an object. You can't throw a class. FE is already an object. It already exists. You can re-throw that. That's the equivalent of somebody throwing to me, then I take that and throw it further on up the line. And there's two shortcuts. You can say throw FE, which is the object, or you just say throw. Re-throw the caught exception. Okay, I think we will stop there. We will do this example on Friday. Questions so far, though? Okay, did everyone get the homework? Yes. Has everyone been able to clone the homework? Yes. If you have not, you should see me sooner rather than later. And OBS. Stop recording.